Hello friends. So today we are going to see the equation for surge impedance and velocity of propagation of travelling waves. So let us see, suppose a particular generator is feeding to the transmission line, and for time being we will consider very small distance dx. Okay, dx is nothing but the length of very small length of transmission line. Now if we consider for very small time dt, the current in the transmission line is nothing but I, and the voltage build up, it is nothing but E. Okay. So, what is happening? The EMF which is fed to the transmission line, it will get balanced due to the flux induced in the transmission line, and that flux is produced by, we can say, I. Now, let us say suppose L is nothing but the inductance per unit length. If we consider the length of transmission line is dx, then the inductance of this length dx is nothing but L dx. Inductance of line length dx is L dx. Now, we have to calculate the flux which is generated in the transmission line. So, how to calculate flux? We know that flux is nothing but the product of current into inductance of transmission line. So, the flux, magnetic flux set up in the length dx is, let us say, suppose it is d phi, which is equal to, as I told you, it is nothing but the product of current into inductance. So, it is I L dx. So, let us say suppose this is equation number 1. Now, next we have to calculate the EMF, that is back EMF. The equation of back EMF E is nothing but d phi by dt. It is nothing but the change of flux, means cutting of flux with respect to time. So, E is equal to d phi by dt. We know that d phi is equal to I L dx. So, if we replace this d phi in this equation, we will get E is equal to, what is d phi? D phi is nothing but I L dx. So, it is I L dx upon dt. So, what is dx upon dt? Let us say suppose dx upon dt is equal to small v, okay, where this v is nothing but velocity of propagation of wave. Velocity of propagation. Now, let us say suppose as we know that current in this particular transmission line I, it sets some charge, okay, and you know the relation between current and charge, I is equal to dq upon dt. We know that I is equal to dq upon dt. So, what is dq from this equation? dq is equal to I dt. So, dq is nothing but the charge which is set in this particular portion of length dx. Okay. So, dq is equal to I dt. So, we can say that the current I set a charge of I dt at the time of, let us say suppose dt, that is a very small time. So, in time dt, the charge set up by current I is nothing but I dt. Fine. Now, if we consider let C is nothing but capacitance per unit length. Capacitance per unit length. Now, what is the length of this particular portion? It is dx. So, the capacitance of this portion is C into dx. So, therefore, the capacitance of length dx is c dx. Now, what will happen? Due to this charge, dq, it will remains on transmission line up to the when it will get charge up to the voltage E. So, we know the relation between charge, capacitance and voltage. We know that C is equal to Q upon V. Instead of V, I will write down here E. So, C is equal to Q upon E, but the distance is very much small. The capacitance of this distance is, as you know, it is C into dx. Q, the charge developed in this region is I dt. So, I will replace here the C by C dx. C dx is equal to what is Q? That is very much small, that is I dt upon E. Okay. So, I will do some rearrangement for current. From this equation, the current I is equal to, it will be E C dx upon dt. Again, what is dx upon dt? Dx upon dt is nothing but phi, which is nothing but the velocity of propagation. So, let us say suppose this is equation number 3. Before that, let us say suppose this is equation number 2 and this one is equation number 3. Okay. So, what we will do after that? So, we got the equation of voltage and equation of current for that transmission line in terms of velocity of propagation. Now, let us take a ratio of this E and I. So, I will divide equation 1 by 2. So, what will be that? I E upon I, it will be, what is E? It is I L V divided by E C V. So, if I do some rearrangement, this I will get multiplied, this E will get multiplied. So, it is E square upon I square is equal to what else? L upon C, and this we will get cancelled. So, if we take the square root of this term, it will be E upon I, which is equal to under root L upon C, and it is denoted by Zn. Now, see here, why to denote it by Zn? Here E upon I is nothing but the means the ratio of this, the unit of this particular equation or ratio is nothing but it is same as the unit of impedance. So, this particular equation is called as or denoted as Zn, which is nothing but the natural impedance or surge impedance. Generally, the value of surge impedance, it is 400 ohm to 600 ohm for an overhead line, and it is near about 40 ohm to 60 ohm for underground cable. So, I will just repeat once. What we have to do? We have to just calculate the value of surge impedance. So, what we did? We have considered only a distance dx. For that distance dx, what is L? L is nothing but the inductance per unit length side. So, we have to find out the inductance for the length of dx. So, it will be inductance of the length dx is L dx. Now, magnetic flux setup, it will be d phi, and it is given by, as you know, it is the product of inductance and current. So, what is inductance of this length dx? It is L dx, and the current is I. So, I into L into dx is nothing but the d phi, and what is back EMF? E is equal to d phi by dt. If we replace the value of d phi in this equation, E will be I L dx upon dt, and dx upon dt is nothing but v, where v is nothing but the velocity of propagation. After that, same way we have derived equation for I in terms of velocity of propagation. So, it is given by E c into phi. Now, finally, we have derived the equation for, let us say, surge impedance. Now, what we will do? We will multiply equation number 2 and 3. What is equation number 2? E is equal to I L V, and equation number 3, I is equal to ECV. So, let us multiply equation 2 and 3. So, E into I, it is equal to ILV into, it is equal to ECV. So, what will happen? This E and I will get cancelled. E into I, this will get E into I, which is equal to LC into V square. So, this will get cancelled and V square will be, from this equation, V square will be 1 upon LC. If we take the square root of both sides, V is equal to 1 upon under root LC. This V is nothing but velocity of propagation of travelling wave, which is given by 1 upon under root LC. So, what we will do? We will substitute the value of L and C for transmission line and find out the value of V. So, what is the value of L and C? We will substitute in that equation. We know that the value of L, it will be 2 into 10 raised to minus 7 log to the base E d upon r, and value of C, it is 2 pi epsilon 0 epsilon r divided by log to the base E d upon r. So, if we place these values in this equation, first let us take the product of LC. So, it will be, after doing the multiplication, you will get L into C, it is equal to 4 pi epsilon 0 epsilon r into 10 raised to minus 7. So, let us place this value into equation of V. So, V is equal to 1 upon under root 4 pi epsilon 0 epsilon r into 10 raised to minus 7. So, if you solve this equation, you will get final answer 3 into 10 raised to 8 meter per second. Now, this is nothing but the velocity of propagation for travelling waves, where the value of epsilon r and epsilon 0, where epsilon 0 is equal to 1 upon 36 pi into 10 raised to 9, and epsilon r, that is relative permittivity, which is equal to 1. So, from this equation you can find out that phi is equal to 3 into 10 raised to 8 meter per second. So, if we consider for the same value, means if we consider the total length of transmission line for throughout total length of transmission line, the velocity of propagation, it remains same. But what is happening in case of cable, the value of epsilon 0 epsilon r, it may get changed, and it may means velocity of propagation of travelling wave, it may change for, we can say, underground cable. Now, so this is nothing but the mathematical expression for travelling waves, but if we consider we have to represent through waveform. So, the travelling wave for voltage and current, travelling wave for voltage and current, it can be represented through an infinite rectangular wave. So, graphically it may be for voltage and current. So, it is represented by infinite rectangular wave. So, this is all about surge impedance and velocity of propagation of wave.